love the chase and the hunt, and I set the pace when I'm running. I always
Namaste Friends. So today in the entire chapter of Python, it is 93. We are 7 short of 100. And on the science by Python, this is chapter 5 and part 2. And with today, we'll actually conclude this. As you all know, yesterday itself, the lecture was at least 4 minutes and 30 seconds or slightly more than that. I'm pretty sure today it will be the same or even slightly more than that as well. So that is why I actually split it into 2 parts. All right. So what did we actually learn with the graphs? That these are essential data structure, and SciPython actually provides a module called SciPython.sparse.cs graph for working with the data structure. And we also saw the adjacency matrix, which is the n by n matrix, 2 by 2, 1 by 2, 1 by 1, 3 by 3, 4 by 4. So we all saw that. Yesterday we left at the dijecta, which is used to find the shortest path. So today we are going to be seeing a lot more commands. So the very first one is called as the Floyd-Warshall. We use a Floyd, it sounds like a name, right? Some name of a person, right? So when we use a Floyd-Warshall, it is also used to find the shortest path between all pair of the elements. Okay, it is between all pair of the elements. So let's actually take this and let's actually run this, all pair of the elements. So if you import this numpy as np, and then we actually do the sparse CS graph, and then we import this Floyd-Warshall, and then we import the CSR, row matrix, and then we have this 3 by 3 array, and then we say this new array, and then we print this Floyd-Warshall, and then we see the return produces a true. This is also the shortest path between all the, between all the pairs of the array. Okay, so if you see, this is what it is. Okay, this is what it actually gives me. Shortest path between all pair of the elements. The next one is the Bellman-Ford. The Bellman-Ford method can also find the shortest path between all pair of the elements, but this method can handle negative weights as well. So we have the positive weights and we have the negative weights. Finding the shortest path from element 1 to 2 with a given graph with a negative weight. Okay, so let's actually see this. So here we have a negative weight. I'll also show you that. It's here. So in this case, we didn't have a negative weight, but here we have a negative weight. So this is the difference between the Floyd-Warshall and Bellman-Ford. The rest all is more or less the same, other than wherever the Floyd-Warshall came, it is a Bellman-Ford here. So this can actually handle the negative. Very simple. All right. So we are going to see the depth first order. But the depth first order method returns a depth first traversal from a node. Depth first traversal from a node. This function takes following arguments. The graph, the starting element to traverse graph from. Okay, the graph, the starting element to traverse a graph from. And then we have it here. I actually put it in this manner. Everything is the same, whether it's Floyd-Warshall or whatever, depth of first order, remaining things is the same. So I actually do this and I actually get this thing. So I do this here. It returns the first traversal from a node. Okay, first traversal from a node. So that is what it is, a depth, this thing. All right. Now we have a breadth first order. So the breadth first order method returns the breadth first traversal from a node. Same thing, it takes the following arguments, the graph and the starting element to the traverse graph from. And this is, this is the thing. Code, rest all is the same. So breadth first order, here it's a 4 by 4 matrix, and we take the breadth first order, and this is what it is. So what did we learn? We learned about the breadth first order in order to find, the breadth first traversal from a node. Okay, we also saw, the depth first order, breadth and depth. We always say the breadth and depth. Right? So the breadth also we saw, the depth also we saw. We saw the commands, we saw the Bellman-Ford, and we saw the Floyd-Warshall. So this is the shortest path, and yesterday we saw the dijecta, which is also a shortest path. So with this, we actually conclude the graph. I trust you have actually seen my lecture. probably understood it, probably enjoyed it. If you have any questions, kindly contact me and I should try to explain to you to the best of my abilities. Like always, I'd like to thank two persons. One is you for giving me your golden time, and the other is my wife Jayashree for allowing me to follow my passion. Till we see next time, thank you, take care, and cheers.